Okay, so we're starting our last set of numbers, the rational numbers. Definition of a rational number is it's a ratio of two integers. So things like 3 over 5, negative 12 over 7, 826 over 347, negative 8,000 over 171. So yeah, we're dealing with fractions. Now, I want to just show you something quick. I actually learned this on Twitter one day. That 4/5, if I talk about this, I can talk about this thing called the fraction bar. And I don't know if you think about it in the same terms that I do, because I think of it as being division. I see this. It's like in algebra when I have x plus 3 divided by x plus 2. And now here's a little cool, interesting thing. The division sign is really the fraction bar, but we don't know what the numerator is and we don't know what the denominator is, so those little dots represent the numerator and denominator in the division symbol. There, you just learned something. Okay, so I'm going to do kind of an overview of this section 6.1, picking pieces. I think you know that if the numerator is less than the denominator, so a over b, and the book will say, yeah, the absolute value of a is less than the absolute value of b. That's in case we have something like negative 3 over 5. Still the same thing. We call it a proper fraction. Because it's not a whole, it's a part of something. If we go the other way, say negative 15/12, now the absolute value of the numerator is greater than that of the denominator. It's an improper fraction. And hopefully you remember things like 5/3, 5 divided by 3 is 1, remainder of 2. You can write it as a mixed number. Okay, I'm going to do fractions with a couple of diagrams. Okay, we always talk about the whole. So in this case, my rectangle, this is the whole. I'm going to divide it into 5 equal parts, maybe. That's the big thing when we're doing this, is these are 5 equal pieces. Equally sized, I guess. And so that's my denominator. If I give you a numerator, so I chose 3 of the 5 equally sized pieces. That gives me the fraction 3/5. So the denominator, that's how many equally sized pieces we divided the whole into. And then the 3 is the number of parts of the whole that we selected. Okay, I'm also going to show this on a number line. Diagrams are big on fractions now when you're teaching children Not so much when I grew up. It was all symbols to me. I don't think I really understood what a fraction was. So I'm going to look at a number line. I'm going to go from 0 to 1. So typically, this is meant to be the whole. But not always, because I'm going to shift the whole on you in the next example. So I'm going back to 3/5. So what we can do on a number line is, okay, I'm going over 1/5, which is that 1 over the b, the denominator, the 5 equal pieces. And I'm going to add, 3 of these to give me the 3/5 part of my fraction, with 1 being the whole. So it looks a lot like my rectangle. If I just extend the rectangle out, I had 5 equal pieces, and we selected 3 of the parts. Now, what do I mean about the whole shifting on us? This is when fractions get confusing. Because suppose now I go out to 2. And this is now my new whole. I can think of this being like a candy bar or a rectangle, but that's my whole. Notice now it's longer than it was before. So where is 1/2 now? Where's 1/2 of the whole? Well, if I think of it being a candy bar, I cut it in half. 1/2 is right here. Notice that now 1/2 on the number line is now where 1 lies on the number line. That's because my whole is larger. What if I ask, where is 3/4? Well, here's 1/2 and 1 more quarter. Here's 3/4. Now I'm at 1 1/2 on the number line. It's confusing because typically on the number line we say 1 is the whole. Now I said now the whole is 2, and now my fractions change, but notice they're okay here. That's definitely a half. It just happens to be where 1 lies on the number line now. Okay, let's give another whole. Suppose I want to represent 7/12. Numerator tells me I need 12 equally sized pieces or partitions. I'll use the word partitions a lot because that's what we're doing. We're partitioning this rectangle into 12 equal pieces. Now, I'm going to break you of a habit really quick. Do not try and do this. You can see just how messy it is, and you'll be lucky if you get 12. It's really hard to see something like that. So very early kids learn, and I learned, that if I'm going to make 12 equally sized pieces, it's a lot easier for me. Let's see if I go 4 this way, and then do my thirds this way, and notice now I have beautiful 12 equally sized pieces, kind of. And I can now select 7 of them. And I represented my 7/12 in a much easier manner. Now, I'm just going to show you kind of where we're going. Because you grew up with symbols, probably just like I did. And suppose you did 2/3 of 3/4. Could be in a story problem, could have been on a worksheet, but you were taught that of means multiply. And then you were taught, okay, it's all symbols. You just multiply across and you get 6/12. You learn to reduce to 1/2. In this course, you know what's coming up. Why does that mean multiply? Why do we multiply straight across? Numerator times numerator, denominator times denominator. Well, I'll show you by partitioning, and I end up showing this quite a bit. So don't worry if you don't understand it this first time. But I'm going to divide into quarters. Okay, because I want 2/3 of 3/4. So here's my 3/4 I'm going to look at. Now I want 2/3 of that 3/4, so that's why I go over here, and now I partition it into thirds, and notice what I got? I got 12 equal pieces in my whole. Now, here's 2/3. I want 2/3 of my 3/4. That's this many. So 2/3 of 3/4, notice I got 6/12. 3 times 4, that gave me the total number of pieces I had. 2 times 3, that gave me the number of parts I selected. So that's where we're going, is to find a deeper understanding of fraction, multiplication, addition, and division. So that's the end of this part.